is the open source software, software and data for big geodata, and how do we choose between R, Python, Julia, and different data formats. So that's more or less the question, but there are many sub-questions, and we'll talk also about the future a bit. So that's more or less the... Okay, yes, the camera. Let me see. Okay, yeah. Now it's working. Or maybe I just keep this video. What do you think? Oh no, you need the one. Okay, let me see. I will stop sharing. I'll do it again. This one. Okay, now you see me. Great. And now I share again. Yes. Yes, it's a come link. Okay. So let me share the screen one more time. Yes, share. Okay. So yes, welcome one more time. This is a discussion forum on open source software and data formats of big geodata, and we have with us here all the lecturers from the summer school. So Valentina, you can also zoom on the table. So we just show the lecturers are here, and we're going to basically run a Slido questionnaire, and everybody can participate, including you people online. You can participate. I send a link, and as soon as I kickstart it, you can enter your opinion, and you can vote on things. And let me just emphasize, it's anonymous. So we will ask about your supervisors also. So just be honest, and it's anonymous. There's no way we can find out who wrote what. So it's really how democracy actually has to run. Also, you have to have anonymity. So let's see what comes out of that. As you see, we already discussed some of the things. This thing between R, Python, and Julia, we had a very interesting session. And we, thanks to Christoph, mainly we looked at, we really zoomed in and looked at the speed of computing and the usability of some packages, and we did some comparison between R and Python, and then also thanks to our colleagues presenting Julia and Julia Geo. We also saw some advantages of Julia. So there's a lot of discussion already happening, and it's also happening now in Twitter. So please follow Christoph tweet to join the discussion. There's quite some post on that, quite some activity on that tweet. And also we have people connecting now online. So please, if you have questions, ask questions, just use the chat. We are almost 18 lecturers, I think, this year. Lecturers and organizers. And we are super happy you're here with us, so we can really discuss these things in detail. And just to show to the online participants, the people that are joining for the first time, we are here in Siegburg. We're running a 1-week summer school, and we've been working on different topics, and it's quite a rich summer school, and it's a really fantastic place to be. So just to give an idea of feeling for other participants, we're kind of a bit tired also at the end of the day. So we have to make it a bit amusing this session. So we pick some spicy questions also. But in general, this is just to prepare you. We'll ask why do you use open source software, for which purpose, what are the biggest challenges, and then reproducibility a bit. We'll talk about that, how much is important for your work. Then about data formats. So we'll talk a bit about software data formats and which data you use and what is important. And then also with Julia, R, Python, and if you find out that, for example, one language impresses you more, let's say now we're exposed to Julia, it's the first summer school with Julia, do we do next year summer school, do we do 2 days Julia or 3 days or no days Julia? So that's a bit of a question. And then of course there's a question, how can you best contribute to open source? So please, open the URL, everybody get it on your phone, on your desktop, And let's go and see. So the first one, what do you do now? Just press the button. Yes, let me see. So I press the button, but need to log in.
But people need to see the QR code first.
Ah, they're asking for the code.
It's very difficult.
Yeah, oh wait. Let me see. So the QR code
Maybe you
here.
can click on the QR code.
Yes? You just tell me when can I start.
Okay.
Okay? I mean, if I press on this thing, interaction, right?
Yes.
Then it opens just, it just puts me
It's
here.
open, it's open.
Ah, it's open in the slide, no?
I activated it.
Okay,
Pause.
but I don't see it. Okay, so it's activated, you can vote, let's see.
I can already see the results.
Okay, great, and I cannot see the results, that's a bit frustrating. Let me see if I can show it here. Let's see if I go here. I go to the first one. Okay, I see the results. Fine.
You can just show results.
Yes. So here's the things popping up. So the keywords that define your area of research.
Show results on this.
Okay, on the big screen, yeah. No?
You have to present something. See results.
Ah, present, sorry. Okay, so here it comes. Okay, now we get it. And now we can just go to the next slide, right? The next question. I don't have to go to Google Slides again. Okay, great. Okay, so we can stop. I think it's not changing anymore. So here's the word cloud. Just the introduction that we. Just introduction to see who we are. So we are remote sensing, primarily Earth observation, but there's a lot of individual words. So, but so that was the first question. I don't think we should have to comment on this. I think we can go to the next slide. Next one is this one, right?
Yes.
All right. Second question. Enter keywords that you associate with high quality science research. And there's somebody asking questions.
How you remove the?
Oh yes, sorry. There were some questions.
This is the question general. If you want to go back to the phone, you have to.
Yeah. Okay.
But you have to decide here.
Oh, this is the previous question.
No, that's okay. So we're still expecting. Please enter. We don't have unlimited time, so we can limit to 2 minutes, I think, per question.
Yeah.
Reusability.
You have the right question. Yeah, I can now results. Yes.
Software quality, modest claims, interesting. Literate programming, very nice. Open data, very good. It's I still, well, literate programming, this one, it's very correct, very relevant, but the reproducibility, the biggest frequency. Okay, we go to the next one. I think here also there's nothing much to, this is still just warming up. Let's see the next one. Do your supervisor support reproducible research and open source solutions for operational work? You can be honest, your supervisors cannot see how you voted.
You're your own supervisor.
Well, if you have a director or rector of university, I don't know. Everybody has a supervisor. There's only few people on the planet don't have any supervisor. Okay, interesting.
A biased group of people.
Maybe, but there's people online, so I hope people online are also voting. If you have any problems with voting for people online, please just let us know. But the URL is in the chat. Okay, so majority happy. This was a question I didn't know which way it's going to go, but there are some 15% say no, they find it irrelevant. So. Okay, next one. What is this? Okay, which is your current favorite programming language for geospatial analysis?
Bash, nice.
Yeah, can I
Well, since this
select
morning,
more than one?
You can do more than one, yeah.
No, you can't.
You cannot.
You cannot?
No.
Oh, sorry. Because it's favorite.
No,
It's a favorite, so
Can
it's
I
not.
do all of the above?
You can say all of the above, yes. Well, this is a bit obvious, but
Julia has 0%.
well, I just picked all of the above. So I saw just Julia dropping
Julia
0.
3%. Julia 3%, yeah. But please.
Thanks.
Okay, I think it's stabilizing, so I can go next one. Which new language would you like to master as soon as possible that you think shows the highest promise?
Yeah.
Oh, Julia's.
I don't know.
Yeah, it's very interesting to see the dynamics.
Actually, JavaScript.
Can you see how many people are voting? On the top, 37, okay. There are 37. Okay, I think it's also stable now. Let's give it a few more seconds. So it's interesting, so Python, Julia, Python first place, Julia second.
Julia.
Actually, to be honest with you, we are now, I'm thinking the bash is my weak point, the bash and shell, because that's the real work happening. So I will put that on top of all. Personally, I vote for the bash and shell. But any comments? Anybody would like to comment on the results? Are you surprised or?
I would personally add the Rust into the selection.
Okay,
Because
Yes. that's the other.
that's the other.
Okay. And do you agree with this? This is from some paper published, the most common languages in geospatial industry. And they have also women who code, and apparently Python is most popular. Maybe it's outdated, but that's the only thing I could find. Programming languages in geospatial data.
HTML.
HTML, yeah.
PHP.
Assembly is still going strong.
Okay, next one. What currently inhibits you? One keyword from excelling in geospatial data science. Okay, so when we reach 38, then I can go to next one. So I see. And when you write time, I think you mean lack of time. Lack of free time, let's say. Time to follow some course. Bugs.
Thousands of other things.
Work.
It depends. Where's Jakub? You can see who votes. It depends.
I was not the only one. So it depends.
Okay, so when we reach 38, I think we stop. That's the number. Now let's have a quick. So what pops up? Time, independence, and multidisciplinarity. I'm not sure what is meant by multidisciplinarity. It's like I'm working on too many topics, or
Maybe too much work outside the geospatial realm.
too much distraction.
For that, basically, you need to know a lot of things from different fields, and that's.
And then you get the salt. You don't master really anything.
My database.
Okay, that's the last vote. Lack of time, bugs, OGC. OGC inhibits you from excelling in geospatial data science. Okay, there's few votes actually for that. Lack of open data. Any reflection, guys? Is it something you were expecting to see? It's primarily time but this multidisciplinarity, OGC, that's absolutely didn't expect. Okay, next one. What do you recommend is the key to improving computer science, open source literacy of young researchers? But what happened here? No? Show the results, sorry. Okay, so that's a free text. So how to improve literacy of young researchers, computer science, open source literacy. OpenGeoHub video tutorials. Who put this cookie? What is this?
That's
Pretzel. Motivating tutorials. Gentle introductions. I think somebody asked me, is it Ben? Yeah, you asked Ben. You asked about this, how, like, what's the key? How do we get young people to get into this with passion?
You also say that you kind of start earlier, and that's an early career type of scientist.
Okay,
So
that's
it's cool for you.
so start as early as possible.
Yeah.
Kindergarten and you have programming for children, yeah. This is super interesting. Now I see people are really typing like crazy. That's really great. There's a lot of idea. Mocks. more free cloud space. So storage, free storage.
More free computing.
No, notebooks. By notebooks, I think somebody means like a laptop or
Yeah.
Python
iPy
Jupyter
notebooks.
Yeah.
okay. No, this is very good. Use Linux. Overcome big background. Collaboration. Okay, last second, people, everybody is really into this. That's very good. It's good to see. Okay. Any reflection? Higher pay. Young people, yeah, we're not with that money. More than young people. First, soon as they're like 12 or something. Any reflection or anything we missed? Is it anything that surprised you to see? So Linux actually is looks like it's has the highest frequency, and then tutorials, trainings, and then it's a variety of things. But it's all looks couple of things that I also didn't expect. Gentle introductions, mocks. Okay, next one. Somebody's still typing, but it's okay.
Well, once we have all the computing in the cloud, we don't need Linux anymore.
To which R package would you give open source Oscar for being most useful for your work? Yes. Do we have some open source Oscar? We could make it.
Next year.
Can I abstain?
Just write without any symbols, so just the package name, exactly how it counts, because otherwise some packages lose points. So it's a really tight competition between SF and Terra. Stars don't come up. RGDAL also nobody mentions. SP is still there, although it's been buried already. No tidyverse packages, or do I miss them?
There is tidyverse.
Tidyverse, okay. Tidyverse.
It's coming.
GDAL cubes doesn't come. There's ggplot2. Okay, we're almost done. Any surprises? So it's I think it's the Terra and SF very tight competition.
But as you mentioned, it's just interested to see that some people are still very into Arguda or SP or raster, even though we have replacement for those.
Mm-hmm. Somebody wrote Python X array, but it's R package.
I wasn't that.
R packages. But there's a Python question coming up, of course. Okay,
So we will start that.
let's go Python. So which Python library would you give open source Oscar for being most useful for your work? Let's see if something surprising happens here.
Depends.
Also, I don't, Raster.io, is it coming? No, don't see it. Scikit-learn, there's some machine learning. Okay, it's becoming more exciting. There's the raster IO. And what about the for plotting packages in Python? There's the grass Python package. Do I see any plotting package? Ah, okay, matplot, yeah. Okay. We almost finished. OSM NX.
And volume is also, I think, visualization package. Volume.
Yeah.
And OSM is OpenStreetMap?
Yeah.
Yeah.
And just basically just to grab the OSM data or?
To grab the data and do some basic network analysis on that.
Okay.
And some preprocessing.
Well, it came as the first one. It's the winner. So that will be the Oscar, at least in geospatial world. Okay, next question. Put one keyword that motivates you the most to produce new significant data sets. Something that motivates you to make data that can make difference, that can make impact. Fame, okay. Tom Hengel, great. So yeah, you can now pick. If you don't come up to something, you can also just vote. I think. So thesis, PhD thesis,
Now try to write a sentence with all those words.
love.
Thank love, fame.
Oh, so it's very clearly climate change pops up as the most important, basically, theme of our work. I admit it, it's in multiple of our projects now. It is main thing. It's not, of course, something. It's something scary, that you look at. But yeah, it's good to see that it pops up as the most important. It's a surprise for me. I didn't expect climate change. Any reflection? Anything you were expecting to see, and it didn't pop up?
I'm glad that somebody mentioned good sleep. That's
Good
important.
sleep. Okay.
Maintain proper sleep, that's my advice.
Benefit to society. Okay, next one. Enter keywords and data sizes that you associate with large geodata. So you can write either 100 terabyte, or you write some keyword. What is a large data? You know what the Harley Wickham said. It takes a big man to admit that his data is small. So large data is anything that you finish out of memory. Satellite images. Any system where you have to store all the satellite images from one mission. That's large geodata. More than 10 terabytes, I see here. More than 1 petabyte. Is it more than 1 petabyte or more than 1 terabyte?
Yes, both. It's even zettabyte. Zottabyte, yeah. How many zeros?
Okay, we can almost done.
But this one is actually interesting.
Which one? Tell me.
Well, because this is out of memory. And for most of us, that's 16 gigabytes. And
Yes.
then there are also answers with 1 terabyte, 10 terabytes, petabytes.
Yes, it
That's a
sounds.
huge range.
Yes, it's very vague. It's very fuzzy term. Large, big data, whatever. It's a very vague term. That's why the hardware weekend said takes a big man to admit that his data is small. It's just a buzzword now going around, you know. I don't know if there's a benefit of that, but I guess there is a, when you program, you know, when you make code, there's a difference when you do some tutorial with some sample data set, and there's a difference when you make a code to run, you know, whole of Sentinel for whole of Planet, right?
Absolutely.
So there is a difference in techniques, and it's a different science, really.
Yeah. So but
Programming for
most
big
people
data.
here will say it's if it's bigger than your laptop, it's large. And then for some of us, with the smaller part, they say it's indeed probably a whole satellite constellation. Or
Yes. Yeah.
complete data set.
Yes. No, it's interesting to see.
Well, the out of memory is one of the official definitions, right? It's been running around for years.
The definition of big
Yeah.
data is out to be out of
Yeah.
memory.
Well,
So the
it-
data
it-
that
it-
makes you run out of memory.
Yeah.
Okay.
One of many, I would say, but it's certainly one of them.
Okay, next one. Which geographical regions do you normally cover for your work? Just to see a bit. Now we're switching more. We're talking more about data, less about software. So let's see. It's interesting to see that most of people actually work with local data set, local applications. Regional, local, some national, then global. Okay. Which data sets Earth observation data set you regularly use for your work? You can vote for multiple things here. And we saw some of these data sets, they were presented. Also interesting to see, so far Sentinel pops up as the most frequent. Any surprises here? Sentinel number 1, Lance number 2, Modis number 3. Expected? Okay. Which output data formats do you use to share data? Use the most? I put JSON, I don't know. I had to put something, but
GeoTIFF twice.
well, there's the Cloud Open, GeoTIFF, and
No,
GeoTIFF.
yes, GeoTIFF is twice more.
GeoTIFF and Cloud.
Ah, well,
To sum them.
okay, I'm sorry. I think got shortened somehow. Cloud Open, GeoTIFF. I'm sorry. So definitely,
It's
yeah.
also there.
We'll sum up. But the NetCDF,
It seems we still haven't killed the shapefile.
Yeah.
the shapefile is still there. CSV number 2. Is that a surprise? I didn't put the GeoParket, it was too early. But CSV comes second. Is that a surprise?
No.
But I'm optimistic about killing shapefiles. Because I would guess that 5 years ago probably there would be more than 17%. So. We are going there.
I'm
We
a
just
bit
need to wait.
I'm a bit afraid that we pushed very hard for GeoPackage, but we already made flat GeoBuff and Geo4K now. So we should jump the intermediate step, just like you jump Windows versions.
Maybe, yeah.
Once ready, where do you should publish your geospatial data as a node of Figshare hardware dataverse? Open Science Framework, Amazon AWS, use your own GeoNode GeoServer, Google Earth Engine, GitHub, GitLab. Did I put other? Yes. Okay, GitHub, GitLab actually come as number one. To be surprised, it's not a really place to publish your data, right?
Well, it's part of an Python library or so.
Yes. Well, there's a difference between like benchmarking data and kind of official data, full data releases. So I think benchmarking, yes, for GitHub, but still surprised it comes so dominantly.
That's to be small. Very.
What's the limit now for the upload to GitHub?
100 megabytes. 100 megabytes.
100
Per file.
megabyte per file.
File.
Ah. And so Zenodo is 50 gigabyte.
Yeah, something like that. And you can also pay them, I believe, to get a bigger data size.
The GitHub, yeah. And GitLab has higher file sizes, no? GitLab. I think it's like
To be fair,
1 gigabyte.
I
per
chose
file.
GitHub just to share the code that produced the dataset.
Okay. So this comes, and this is a big surprise, people voted for this, but okay. When making spatial predictions using machine learning, should we extrapolate outside the feature space covered by training points? Let's see. So the options are yes, as long as the prediction areas are provided. Yes, but such pixels should come in a separate mask map. No, it can propagate to problems. Not sure.
Problems, I like that.
Deep problems.
That's we make a lot of maps where we probably go outside of the training space.
No kidding.
We made a lot of maps. That's something that Ezer and Hannah published a paper recently in Nature Communications. Well, discussion piece. So it looks like yes, people are against it. The problem is when you get asked to make a map and then if you mask out all the pixels, then they say we don't pay you. You didn't finish your work. That's a bit of a problem.
Well, I would have voted for yes as long as prediction errors can be provided. The question is, can we provide them or not? That's why I did not vote for that, because I'm not sure that we really can, and chose no instead.
You can just put random nodes into places outside of the domain.
Well, you can, I mean, in regression, in classification, you can estimate what are the errors in extrapolation. The question is, this estimate is biased, if it's like what I showed in the slides. If it's too narrow or not realistic. Then you, yes, absolutely mislead. But let's say if you can estimate as high errors because you're extrapolating. Anyway, interesting to see.
We have a lecture about that tomorrow. So.
We have a lecture about it. Hannah is going to talk about it tomorrow. So please join the lecture. And also we have the hackathon. Don't forget, hackathon, want to test this. How bad does it get when you do extrapolation? Even if you extrapolate to 90% of feature space, 90% of points are in the extrapolation space. How bad does it get? So let's take a look at that. Who is doing the hackathon 2? Hackathon 2, anyone? 2 people. Don't be shy, just raise your hand. How's the progress? How's the progress? How is it going? Okay, we have tonight, you have tomorrow evening,
No,
Then you have
it's going,
Friday morning.
it's going
so-
great. You're one of the two.
No,
There's a huge chance that you make it.
and we're working together.
So you are already the winner.
It's a very good strategy. You exclude any competition, yeah. How do you recommend solving the problem of non-standardized data formats? This is from a paper published by Julia Wagemann on the problems of big EO data. And so she published that paper. She did a lot of polls and collected a lot of interviews. And these are one of the things that pop up as the biggest problem. Non-standardized data formats. People use non-standardized data formats.
What does that
What you
mean?
see?
What does that mean, non-standardized?
So that will be something that,
Like,
so like, let's say there's some ISO standards or OGC standards, I don't know, and then you use something that is not there, I don't know.
so COG is not a standard, right? COG is not a standard.
Or do you mean like
There's an application to become OGC standard, no? It's in process, you
It's
can
in
find it
process.
online. So,
but do you mean this or more like a table in a PDF?
no, she picked up 5 things that popped up in the paper, and the people said these are the biggest problems. Why of usability of data of application, and they pick up non-standardized data formats. So there are things coming up. So use plain formats. So that's one good point. Use plain formats like CSV. Bring up standard that works for 90% of people. Guidelines, OGC. So there are things popping up. Tidyverse, funding, education. Use de facto standards.
That is me.
Switch from shapefile.org. Did you know about
I
it?
think it's standardized or not. As we shape file, maybe not.
No, it's proprietary.
Use
I'll
ISO.
show you at least. Yeah.
ISO. You have to choose ISO or OGC.
First have to buy these standards.
True, yeah.
It costs 40 pages, 150 Swiss francs.
Maybe the solution is just to help GDAL be more, have more things and have more functionality to convert.
That's what I said, use de facto standards.
Okay.
But I say less format, so less features. Just drop the shapefile writer driver or something like that.
Okay.
Force it.
And nobody can convert anymore to something else.
Let's open a GitHub issue tomorrow about Rocker.
Drop the writer, that's a clever.
Even will be happy
Okay.
about it.
Make them read only, yeah.
Let's see, similar question also from Julia's paper. How do you solve the problem of too many data portals? It is true, it's it can become overwhelming. Even just today I look at this land cover projects, it's like 4 projects in parallel, global land cover and data portals. And they all call something like global land cover or something. OpenEO, Stack, stop using asset rollers. I see David, you are also connected. It's my PhD supervisor, David Rossiter. So let's see, he put his name on the board. Portal of portals. There is a geoportal.org made by the Geos, it's called System something.
But you know, then we'll use.
Geoportal.org, that's the place where you should be able to find all the things.
But Tom, you know, but then you will have one portal of geoportals, and then you'll have another competing geoportal of geoportals, and then we will need geoportal of geoportals to have it all.
Yes,
Like
and
check
I'm not saying
24.
these are,
Yeah.
you know, this is a really open book exam, so I don't know what's the solution. But still, I would say,
They tried it, Portal of Portals, the GeoDAP, the Geo Discovery and Access Broker, was meant to be a portal of portals, but nobody ever used it. They just spent 50 million on it. It wasn't a success.
collaboration, OpenEO. Well, maybe one solution is that, like societies, like Phospho-G or something, that they give awards, and so that, you know, everybody can see from all the portals, this seems to be according to our culture, I don't know, and what we find useful. And so they expose some portals so that still people don't get confused now where they go. Maybe that could be something we could do. That we give these awards like the Oscars for the open source. We also give Oscars for the data portals. Okay, standard API. Last question. How do you recommend solving the problem of difficult data discovery? Stack, education, Twitter, stackindex.org. Stack came a few places, Stack Index. This IAN, I'm not sure what that is. Does anybody knows?
So translation,
Translation library or something?
well, standard I believe implemented.
Is it LAN or IAN?
I
Dois. Twitter. So that's easy. You just go on Twitter and you search.
Ask them.
Okay, well, that was the last question. We still have some time. We can open the floor. Let's see if there's questions from Zoom. If there are any questions, let's start first with the online participants. If there are any questions, did you see some question? So please, there's 30 people online. If you have a question, you can ask it Q&A or something.
Yes.
there are several questions.
On Slido and Q&A, there are questions.
Okay, let me see. Let me start with that, then with the Slido. So there's a question. Given the substantial overlap of R and Python for geocomputation, should the long-term goal be to choose one of them and join forces?
So that all the R developers continue working on Python, or all the Python developers continue working on R. So that is it.
Yeah, you
That's-
drop one, basically. You
You
drop
drop
one, that's the.
Yeah, that's an interesting thought.
That also goes on Julia, then. Julia.
Oh,
Also,
I agree here actually. Well, we already do it somehow with Guido and Gio's approach. I mean, we're all building on top of them, so at least there we can cooperate. Of course, it's essentially quite stupid that we invent a new language each time and have to build a complete geospatial stack. And once we've done that, there's a new language coming out.
Maybe that's a job production, basically.
Yeah, it's one of those. There's a book about that, right?
Well, the advantage I see is that with having different language implementations is that you get different ideas about APIs that partly come because this language offers different possibilities and partly come from the taste of the implementer. And also that the spatial things you implement in that language then lives in the language where you can do all kind of other things. And there's all kind of other things is pretty much different from Python, Julia, and R. right? R has all this whole bunch of statistics and trash. Julia has the high performance thing. Python has this generic programming language. You can do Dask, you can do web service, everything. So it gives new opportunities, new views, and new possibilities. So I see it as a possible, sort of, as a bigger ecosystem, which is just positive in many respects.
Well, let's just give it a vote. Let's not make it complicated. You vote, not you guys. You just vote. The vote is whether you would vote. So if you vote, you're for. If you don't raise your hand, you're against. That we join forces. We pick up one language and we join forces there, and we drop the other things. So are you for that? Nobody's voting for that. So the answer is unanimously that we don't want it. So we will continue developing in parallel and overlapping. So that's, I think, what the community thinks. Okay, that was a big question, and people voted for it. There's this question from your experience: who are the main customers of these developments? And I think it's more about software here. Who are the main customers of the developments? Well, maybe I don't know how to answer this. Sounds like a bit.
Maybe it was related to one of the questions because
It's
it was asked
yeah.
yes.
I cannot see which question was it.
I tend to think of users rather than customers.
Yeah, we're not
Yes.
paying.
Except they're not paying, yeah.
Well, some are, but
Okay.
So let's go to the next question. Challenges of establishing open source community as the standard research approach. What are the challenges? So I guess, well, you don't get any recognition, right, in academia. If you establish open source community, it doesn't help you with your career.
Well, joining these communities usually takes a bit of time that researchers often don't have. So they have to schedule, they have to program, and on top of that, they need to join these communities and also spend time there.
And it's all voluntary, it's all low budget.
It's voluntary work.
Yes. Anything else? Well, the many communities already exist, so there's you want to create a community, but if it's already exists, maybe it's called a bit differently. And it's difficult to get people. Okay.
but it's I mean, if you don't do it, if you don't establish a community, there's a large chance that your software will pretty soon die off.
Yes.
Yeah, because it's not going to. Software only has value if it's used.
That's
It
all
doesn't
this.
have it doesn't have value by itself.
So all these EU projects, they get funding, research funding, right? And then as soon as the money runs out, poof, if they don't make a community,
Yeah.
and
So
if it's not vital
a
community,
lot of software born dead.
yes. Okay, NetCDF, yes, no, format for big Earth observation data. You want to give it a vote? So if you think that NetCDF should become standard format for, putting all the Sentinel.
Well, a standard or the standard?
I think they want to say the standard.
No, I don't think so.
No?
No.
I think they want reasons why, yes or no.
Why yes, no, in NetCDF. Okay, well, first whether it is, and then if it's not, why no? Is it?
Well, yes, because that is well understood by a very large climate and forecast community, meteorology and so on. They are delivering CMAP 6 now in NetCDF. That is how much? 20 petabytes or something like that on climate runs, climate simulations. You can put pretty large data sets in NetCDF files. If they get very large, it's not so good. That's why they are developing ZAR as an alternative that is more performant, but basically uses the same data structures.
So let's also
for very large data sets, it's more likely that in 5-year times we will be looking at dominantly ZAR files.
Okay.
We will read climate simulations from ZAR files.
And NetCDF is open format?
Oh yeah, has been there for 40 years.
40 years,
Is
okay.
well understood. Is not a formal standard. Who cares?
Okay. But it still has some advantages.
Oh yes. How do you write
Some multi-array.
data cubes?
Yes.
Yeah, time, space.
Okay.
And with OpenDAP, you can actually access it.
Yeah, it's
Sufficient.
to write to web service selections and so on.
Please vote for the questions because I cannot scroll to everything, so I will just use the ones that pop up as if you give them enough votes. If there's no votes, I won't ask. So please vote for the questions. Yes, please, Jakob.
I just want to quote Michael Sumner because I think he said that if you think that your data can be used as GeoTIFF, just use GeoTIFF. Don't put that as NetCDF. There are some reasons to use NetCDF, but if your problem that's not maybe that's too much, just use GeoTIFFs and so NetCDF.
And forget about the time, right?
Yeah.
Yeah, but forget about time as a dimension of your data.
It's sometimes that's.
Who cares?
It depends, Ezra, I think, because for example, sometimes like I've seen annual data sets, and the time is only about you have 5 years, and you're putting that as NetCDF with uncompressed format with broken CRS, and then you care about time, but you don't care about projection, for example. So I've seen like many broken data sets because of that. I agree that. I'm just saying that it's not about like stopping using time. I'm saying that think about if that's necessary for you or not. If not, it's good. If the time is important for your purpose, yeah, let's use NetCDF.
Yeah, and otherwise we just put time in the file name, right?
No, I'm not saying that to do that always, but
but that's the consequence of using geocaching. So encoding time in your file name. No, it's okay. I mean, it's an opinion. Yeah. I don't share it, but I know that Mike's opinion too.
And there's also the HDF. It's kind of also multi-array format. That's what NASA uses, I think, a lot. What about that?
Yeah, HDF4, HDF4 motives, HDF5 for modern things. NetCDF4 is implemented in HDF5. Yeah, so it uses HDF5, but this is just a constrained format of that. Yeah, so essentially, if you're using modern NetCDF files, you're using HDF5. You just don't notice. So yes, that's there and it's good. Useful.
But the NetCDF, if it's a huge data, you want to visualize it to something, you have to extract them. There's no like Cloud.NET now. It's magic. I mean, to distribute, visualize.
Yeah, but you can screw up cloud optimized GeoTIFF too. I mean, there's hundreds of options how to chunk things, how to order things and so on. So if you optimize it for one particular axis, it's not optimal for another kind of axis. So it's not like there is one cloud optimized GeoTIFF.
But the way I understand this, your biggest criticism is that lacks the time. You cannot.
Yeah, GeoTIFF doesn't. You can't do time series. You can't register the time in a proper way such that you get it back when you read things.
Okay, but let's say if you solve that with the GeoTIFF.
That's not going to happen.
No.
No.
Okay.
Well, look at the OGC standard, whatever proposal, and see if it's there. Like timestamps of different layers or time series of images.
Okay.
I don't think it's going to happen.
Because in GeoTIFF you can put in header. I mean, you can put all this.
Yeah, you can put in
metadata
tags,
and
of
stuff.
course. You can put in metadata, but it's not standardized.
Okay. Okay. No, it's very interesting. Flat GeoBuff or GeoParquet GeoArrow.
It depends.
It also depends.
But it depends very much on the use case because those are very complementary file formats. FlatGeoBuff is a row oriented. So, and it has a spatial index, so it's very fast when you want to get a small spatial portion of it with all the data for that small part. Parquet, as we heard before, is a columnar one. So if you want to get whole column quickly in memory, there's going to be a much better option than FlatGeoBuff. But it depends on the use case. If you want to render it quickly on a web map, it's going to be FlatGeoBuff because otherwise you will struggle with Parquet. But if you want to do analytics on the whole file, then Parquet is the option.
Question. Well, I see here on the top. Given limited time, resources, thank you so much. That's very useful to know. So please, the people that ask Flood GeoBuff or GeoParquet, the answer is both depending on the application. Flood GeoBuff much more better for WebGIS visualization, and GeoParquet better to retrieve the data and that gets bigger chunks of data at the same time.
Yeah, most of the analytics we are doing is columnar in memory. So it's much more efficient to read and write files which have the same memory layout. So Pandas, for example, is storing all the data as columns in memory. Parquet is doing the same. So you're not reshuffling your data and pushing them to a different structure. It's just going up and down.
Okay. There's people now really voting, that's great. So we really have no top questions. Given limited time resources, should one either try to learn both R and Python or focus on one of them? It's kind of the similar thing we had, but this is from students, and yes, very important. Given the limited time resources. So let's say
We can vote on that. It's a yes, no.
yes. Okay, let's vote who thinks that you should, if you think you should focus on one of them, then raise your hand. 1, 2, 3, 4, 5, 6. So there's more saying you should focus, basically switch to Python, right? I think you're Python guys.
Well, I didn't say that. I just say focus. Focus on one.
Yeah.
Okay.
Yeah, I think it takes time to really master one of these, not only of these, but any programming language, like a couple years maybe. So it's better just invest time in just one and really master it.
Okay,
Later
but
it will
isn't it that the programming languages are really very secondary, because you know when you do the work, your language is not going to tell you like how to do some interpolation or classification of land cover. I mean, you have to know your field, right? And you have to know statistics. And, and then you just implement it in programming language. It's just like talking German or French or Italian.
Yeah, but I'm fluent in the one and not in the other.
Another argument against Leandro is that if you have seen both, you can make an informed choice.
Yeah,
Because anyway, you know, whatever you do during your studies is not going to help you. Only when you dive into practice, you learn things.
Plus, you can mesh up. We even saw for Julia, there's a package that you can call R in Julia, and then in R you can call Python. You can use RStudio to make both R and Python. You can mesh up the code, and you can actually make it work.
It helps you
But
on
it's
your
interesting that most of you voted to switch to one language.
knowing both also helps you on your CV when you enter the job market.
Oh, yeah.
Yes, very good point.
I think as a student, you should take a bit of time to explore some options.
Yeah.
So try out different stuff. You will find your way. That's it.
Right,
That's why we do the summer
Sorry.
school also, just to
I need to
expose
go.
people. Okay, we see you tomorrow, Tim.
I have a meeting soon.
Sure, no problem. We'll see you tomorrow. Thank you so much. Thank you so much. It's very good. There's 3 more questions, then we'll stop. Python is faster than R, a cliche or the truth? I think Christoph,
Yeah,
you start.
this is not true. If you show benchmark, which we done today, you can simply see this is false statement.
Anybody else wants to comment? Some Python?
So there are things that are faster,
Okay.
that are currently faster in Python. There are things that are currently faster in R. But generally speaking, both Python and R are slow languages.
Okay, that's the correct answer. So Python is faster than R? No, they're both slow. So remember, that's I think I think probably one of the key highlights of this discussion. Why Terra and SF stars should be united? Why Terra and SF stars should be united? I don't understand the question. Maybe somebody can help me.
Well,
Should it be united? I think that's the question.
there is some overlap between Terra, which does everything, and SF and stars that also do everything. So the question is, should they be united? I guess.
Yes, and both you and Robert Heijmans, you are Dutch kids.
We're both Dutch, but we live in very different
Different time
zones.
Yes.
So yes, it would be very efficient if we would unite it.
I mean, when you see each other, you get along, right? You don't fight.
Oh, very
or
good.
something.
No,
Yeah.
we're good friends, really.
Yes.
We'd
Absolutely.
have different worldviews.
And I think it should be like that, you know. There's no need to force things, and you can combine Terra and SF. Is there any barriers between Terra and SF and stars?
I don't know.
I mean, you can pass the data from one to the other. You can have in one line you run Terra, and the other line you run stars. You have to maybe convert to something.
Yeah.
Do you ever use it?
Terra.
Yeah.
Well, when I run, examples that people ask me to run, then I do, yeah.
Okay, I think we're running out of time. Valentina, just remind me, because we also.
The next one
we
is
have
very. It's about
6 o'clock.
one more question, Tom.
One more question, we stop. Okay, let's see.
About the journal?
This one you mean. Do you think it's difficult to find a job related to geographical data analysis? Where should we look to find geodata scientist job?
Well, Esri Redlands.
Yeah, it's possible, yes. I don't think that's difficult to find jobs. In geoinformatics in Munster, there's a whole institute of geoinformatics. So, and your students, do you follow them?
They usually have jobs before they finish.
Before they finish their jobs, yes. So
we have the same experience from Liverpool. We use
yes.
geography, data science. They usually have jobs way before they finish.
Yes. So to whoever asked this, you don't have to worry. But where should you look to find the jobs? Well, that's not. I think it depends on academia. But absolutely come to FOSS4G. Come to the spatial conferences in R in Python. There's a GeoPython. How is it called? GeoPython.
Talk to Ben Grailer.
Talk to Ben Grailer. Come to OpenGeoHub also. We are looking also for 3 new staff. So please come to come to conferences if you're looking for more research, academia. Otherwise, you can go also to more business related meetings. But I don't think that's a problem. We are actually proud of that, and it's most of the people I know also have careers and they make careers. And there's a high interest. The satellite Earth observation, satellite images market is really exploding. There's so much interest and opportunity. So I expect actually just to get exponentially more and more attractive also for business. And with this thing, I would like to thank you all. I hope you enjoyed it. It was. We will keep these results, and of course, this video. We will edit it. And thank you so much, also online participants, for joining. And thank you for your feedback. And we stop with this. And please join tomorrow. We continue day 4 of the summer school. You can find the links on our Twitter channel, and you can see how you can connect and follow our lessons. Thank you so much. Bye bye.